Today's presentation is about producing higher strength composites utilizing a novel reinforcement wetting additive by Patcham. A little bit about Patcham, for those of you who don't know. Patcham's been around since about the mid-80s, manufacturing in UAE since the mid-90s. Focus on composite additives, accelerators, coatings additives, dryers, catalysts, oil field chemicals. Location-wise, fairly global. There's about 1,200 people in the group of companies. It has primary manufacturing in UAE and in India, in Asia. There's also tool manufacturing in North America and laboratories and offices scattered around the world. Just so you know, you can get the products almost everywhere. We have a very extensive group of agents. And of course, if you know anything about additives, our expertise is interfacial control, and Patcham is, of course, also a very strong player in the metal carboxylate industry or metal carboxylate chemistry. So today's presentation, oh, by the way, you can go, if you want to know more about the company or the history or anything like that, by all means, patchamltd.com, and it's all there. Today's presentation, again, about increased strength laminates, and also we did laminates in with different resins and different reinforcements, and we also did some pultrusion work. So we'll separate them out in two sections. The novel technology I'm talking about in name goes by the name of PADAD FW1065. It's a polysiloxane or polyether polysiloxane chemistry, and it is a unique surface modifier. So this particular slide, I put it in there because I like it. It's what originally attracted me to doing the work with this product. You can see we poured out some resin with and without the additive, and incidentally, the one on the right is with one of our worthy competitors, reinforcement wetting additive. So you can see from that slide, this kind of inspired me to take a look at it. So there's a lot of variables when you're making contact laminates. Number 4 on that list is really what we were interested in, and that's the interaction between the resin and the reinforcement, or the wetting of the reinforcing fibers. This particular one, we used the vinyl ester. We did vinyl ester glass, and we did vinyl ester carbon fiber, and we did epoxy carbon fiber. We didn't do any epoxy glass on this one. And we did focus primarily on short beam shear, the D2344 short beam shear. We did short beam shear, and I'm going to go through why. Probably there's, oh, go back to one. Oh, maybe I eliminated that. Last point on that screen, Dr. Adams, if you go back a few years in the Journal of Composites Technology, I just quote him. It's a good indicator of the fiber matrix interfacial bond. So that's why we chose the D2344. Again, we can go through these fairly quickly. We did the carbon fiber resin at 50/50, glass to resin. The vinyl ester glass we did at typical 35/65. They were 5-ply laminates. The glass had chop strand 450, 4 plies with 1 ply woven in the middle, and I just picked a carbon fiber, a non-woven unidirectional, for the carbon fiber. And then the epoxy carbon fiber, again, a 50-50 5-ply. They were all rolled out equally as you can do it in a hand-laid laminate. Everything was 2-hour ambient, followed by 82-degree oven for 4 hours. So as I said, short beam shear is an excellent measure of interfacial bonding. And here's the results. So you look at boring table, and you're going to see on these particular, this is the vinyl ester glass panels. In the vinyl ester glass panels, we showed an increase in the short beam shear strength of upwards of 25%. That's a pretty significant number. The vinyl ester carbon fiber, we showed 13% increase in strength through just wetting the substrate better and wetting the reinforcing fibers better. And on the epoxy carbon fiber, we showed a short beam shear strength increase of 17%. By the way, I didn't run the Instron. Had these done in the independent lab, so nobody skewed the results. So in terms of discussion, I mean, every laminate's different. You're going to get different results, but certainly the better you wet your reinforcement, the better or stronger, better chance you got of having a stronger matrix. And moving on to Pultrusion. In Pultrusion, we did a dosage study in Pultrusion. We used the FW1065 at 3 doses, and in this case we ran the D638 tensils, the D790 flexuals, and we also ran the short beam shear at 2344. These are just the resin mixes. The control resin had no additive whatsoever, and then 0.3, 0.5, and 0.7 of the FW1065 pad add. Profile we ran, pretty simple, a 3 millimeter by 100 millimeter. We ran it at about, well, exactly 0.4 meters per minute through a 1 meter die at 120 and 160 for the 2 heating zones. If you go back to the resin mixes, there's Trig C and Trig 21 in there, and then Perc 16. So there's three peroxides in there. Fairly simple profile. We got a top and bottom mat and a top and bottom veil, 50 strands of 4800 tex, and then 2 woven up the sides. Something we noted right out of the gate, fairly interesting, was that the pull force as measured on the machine, in this particular case, the machine just measured and converted it to pull force based on the amperage draw of the pull motors. And it's, again, a significant reduction in pull force, up to, well, it went from 35 newtons down to 25 newtons. Everything was kept the same. So on the tensils, on the Pultrusion, the results weren't quite as dramatic as we saw on the hand-laid laminates, but it's still significant in that you got maximum load in the 0.5. I draw your attention kind of the 0.5. It seems to be the sweet spot. We got a basically almost a 10% increase in maximum load and maximum tensile strength. Slightly less on the modulus. Other interesting thing, when you look at these samples, I did kind of cherry pick these things, but it was fairly common right across the board is that without the additive, the tensile dog bones, they completely delaminated, whereas with the additive, obviously they broke because that's what the test does, but they tended to fail right where the grippers were, and they didn't, for lack of a better word, explode like the parts without the additive. And we ran flexuals with this type of linear laminate. You wouldn't really expect the flexuals to be all that much different. We were pleasantly surprised when we saw the modulus go up by anywhere from 10 to 11%. Again, I wasn't necessarily expecting that. And short beam shear, not nearly as dramatic as we saw on the contact laminates, but still significant when you got a 3.8% increase in the maximum load on the shear, on the short beam shear or interlaminar strength, just by putting in 0.5 parts per 100 of an additive. Other interesting thing here, those are all the control specimens, and you can see several of the control ones, they failed interlaminarly, they did break up, whereas if you look at the ones where we used the additive, they didn't fail interlaminarly, they failed at the bottom side, the deflection side. So we had some friends at Pultrusion do some microscopy for us. Thanks for that. And I should probably have put these on the same page, but this is the control, and you can see the single strands not all that well wetted out with resin. And then you can see this is the 0.5. This is the 0.5 parts per 100 of the 1065 on there, and you can clearly see the noise you've got in there, and is the resin that's adhered to the fabric or to the fibers. And this is 20 times on an optical. On the scanning electron, when we went to 300 times, we're looking at single fibers. And again, this is the control. So keep that picture in your mind when we go to this one, and you see all the noise in there. And that's no cheating here. It's exactly the same magnification, and you'll see the fibers are much more swollen and much better surrounded, indicating complete penetration of the fibers using the additive. Again, this is the FW 1065 at 0.5 parts per 100 resin. So I got through this a lot faster than I thought I would, which does leave room for some questions. Really, the summary here, it just tells you that the 0.5 parts per 100 is probably the sweet spot in these applications. Certainly your own fabrication methods and your own fabrication optimization, you're obviously going to get different results, but there's no question better wetting of the reinforcement is going to give you improved strength. So we got 10 minutes for questions. Anybody have questions? Sorry, somebody's going to bring a microphone over. Oh.
Mr. Richmond, congratulations on the excellent work on the mechanicals. What I'm interested to know is there any influence on the resin itself, anything to do with the shelf life of the resin, chemical resistance or pigmentability?
We wouldn't expect any, the answer is we haven't done the actual chemical resistance on it. We wouldn't expect any adverse effects. Certainly not in storage. It isn't reactive. It's a polyether polysiloxane, so there's no influence or no impact on the storage. It can be put in or added to just before usage, or it could be put in at the resin manufacturing stage. It doesn't really matter. I would always put it in before I put in any fillers anyway, because it will not only wet the reinforcement, but it'll help wet the fillers when you're trying to disperse them. So you might as well take advantage of that. But as far as the chemical, I wouldn't expect any, but we don't have any empirical data. Questions? We have one over here.
Is there any experience with RTM or resin infusion? Do you expect similar benefits, or?
I need to get in. Problem is, I was trying to see you through the lights. Yeah, we would. We have. The answer is no. Haven't done RTM, but thanks for the question. I would expect that it would provide similar benefits. And I would urge you to try it. At the very least, it will provide, it will speed your infusion or your spreading of the resin in the resin transfer. And I would expect the similar results, maybe even enhanced results, because RTM is already a pretty good wetting fabrication method. Anyone else? Oh, we have another one over here.
Sorry, does it also work in conjunction with air release additives?
I'm sorry, I couldn't hear you.
Does it work in conjunction with air release additives?
To be honest with you, yes, it does, but I would probably not put them in unless you are having a serious problem with air release. I would go without it. Because it reduces the surface tension, that's part of what polyether polysiloxanes do. It will also give you some air release anyway. So unless you have the problem, I wouldn't put air release in. But no, they're not contraindicated. You can use the two products together. But I would try it first without. I have used the two of them together in certain products. Actually, those laminates had both products in, air release and the wetter. Well, if that's everything, I'd like to say thanks for coming and enjoy the rest of your show.